Today we're going to go over projectile motion. Projectile motion builds upon the concept of position, velocity, acceleration. If you are still confused with those concepts, please check out my last few videos where I explain and go into detail on them. But let's go ahead and get started. Projectile motion is motion in two directions, usually X and Y. The reason it's called projectile motions is because usually the most common types of problems are an object is being launched and it's flying through the air. It is a projectile in the air. And in the air, you have both your X horizontal distance and your vertical distance. So here are some visualizations of common projectile motions. So if we take a look at this first chart on the left, we see there's multiple points where arrows are pointing up uh, horizontally and along the curve. So this is a drawing of a projectile starting from here, and it's being launched along this pathway. And then any single point along the pathway, you are able to find the velocity in the x direction and the velocity in the y direction, calculate for height, etc. The right chart kind of demonstrates more of a fine detailed version of a projectile. So a projectile being launched from the ground has a maximum height and then falls back down, and at every single point you can calculate its movement, its velocity, position, etc. So, one thing to note for common projectile motion, for basic projectile motion, for acceleration in the x direction is 0, unless something is acting on the object. So acceleration horizontally is 0 unless there's an external factor. So meaning I'm pushing um, the object to the right. However, at that point, it doesn't become projectile motion. Projectile motion happens as soon as something is launched. So even if I throw something completely horizontally, as soon as it leaves my hand, that is when it becomes a projectile motion problem. So acceleration is always 0. So this, unless external factor, you can kind of ignore, but that is the general gist. For vertical acceleration in the y direction, it is always negative g. And g in this case is gravity. Negative because the typical coordinate system is drawn like this, where up is positive. So the negative just means that the object is being pushed downward towards the ground. So those are the only accelerations involved in projectile motion. So now that we kind of have a basic concept of what projectile motion is and the accelerations behind it, let's go ahead and go on into some general steps on how to solve projectile motion problems. So step 1, we're going to split velocity components into its components. So we're going to split our velocity into components. And what that means is we're going to split it into Vx and Vy. So our horizontal, this is our horizontal velocity, and this is our vertical velocity. So our Vx is usually written as V naught or V initial times cosine theta, while Vy is V initial or V naught sine theta. And where the theta comes from, if I have an object on the ground here, and I have, let's say, a cannon, and it launches a ball at an angle from the ground. Theta, right? Theta is the angle of launch, right? So in this case, our velocity, so if this is our velocity total, we have our velocity in our y direction, and we have our velocity in the x direction. So that is the first step, is always simplify your components into x, y, because that is what we can solve. All right, step 2 is to solve the horizontal motion. And step 3 would be solve vertical motion. And to do step 2 and 3, this is where we need our physics formulas. So for physics formulas, we always want to know what we are given and where we want to go, or what we want to find. And our physics formulas allow us to do kind of like a scavenger hunt of variables to go from one formula to the next to the next, to so if we, because not every formula has every single variable we need or we have. Sometimes we have to use multiple formulas to get to the answer. So whenever I say physics formula going from given to find is a scavenger hunt, that applies to any single physics concept, and we'll work through that a little bit today. But I just wanted to put that in the general steps so that you are aware of kind of the process. And with that being said, let's go ahead and get into our first example. So this is our pause problem. If you are new to this channel, pause problems just mean um, I'm going to read the question. You guys are going to pause the video, try to solve it on your own. And then once you try to solve it, come back and I'll walk it through. So this is our first pause problem. We have a ball rolls off a 20-meter high table with horizontal velocity of 5 meters per second. Find the time for the ball to hit the ground and horizontal distance as the ball lands. So go ahead and pause the problem and attempt it on your own. Okay, welcome back. Hopefully you solved this successfully and it was easy. But let's go ahead and get right into it. So first things first, as with any physics problem, if you've been watching um, my channel, you should know, always draw a picture. So we're going to draw a little table here on a ground. It doesn't have to be beautiful. I'm going to make the ball red. And the ball rolls off the table with 5 meters per second, and the table is 20 meters high. All right, so our 5 meters per second, this is our VO in our x direction because it is horizontal. All right, so let's start with let's find the time it takes for the ball to hit the ground. So we're going to look at our formula sheet, and I'm going to see what formulas has the variable time that I'm looking for, plus variables that I already have. And from one of my formula sheets, I found this formula: y is equal to 1/2 gt squared. That is a very common vertical or initial velocity formula. Go ahead and kind of get used to using this one. So let's go ahead and get started. So for y is our initial height, right? So if we have our coordinate system like this, y would be 20 is equal to 1/2 g is 9.8, and then t squared. T is what we're trying to find. Let's rearrange everything to the other side. So we get t squared is equal to 4.08, and then t is equal to about 2.02 seconds. So that is one of our answers. That is the time for the ball to hit the ground. Notice how we only used the vertical component. Um, we didn't use the 5 meters per second squared. We only used the vertical component, the height, and the acceleration due to gravity, right? Because it's vertical, we know from above that there is an acceleration to gravity, right? And that acts upon the object. So let's go ahead and now solve for our horizontal distance. So again, go back to your formula sheet, see what formula you have that uses variables that are given and what you are trying to find. So on my formula sheet, I see x is equal to vt, right? And we just found time, so that's good. And we have v, this is v naught, and we have v naught as 5. X is the horizontal distance, so I'm going to write this as the horizontal. So now plugging everything in, we have, this is 5 times 2.02. Our horizontal distance is roughly 10.1 meters. There you go. Hopefully you got similar answers. If you have any questions or you got something different, please leave a comment down below and I will try to respond to you as soon as I can. Or if you had a different way to solve it, please leave it in the comment section below so that other students can see how you did it. Because there's more than one way to solve these types of problems. So notice how we used vertical motion to find time, and then we used time to find horizontal motion. So that's kind of where the scavenger hunt comes in. So if you noticed this formula first, you might have been like, oh, I have two unknowns, right? Those two unknowns. But you found this formula that allowed you to solve for time, that then allowed you to solve for here. So there's kind of steps to solving it, and each step can be an answer. It could be just something random, but that is what I mean by scavenger hunt, that there are multiple steps always to find any physics problem. So as long as if you're ever stuck, just think, okay, this is a scavenger hunt, this is a game. What do I solve for next? All right, let's go to another problem. This problem is going to be a bit harder. This is also a pause problem. A projectile is launched at 20 meters per second at a 30-degree angle. What is the time in the air and the max height? Go ahead and pause, try to solve it on your own, and I'll be back when you're here. All right, welcome back. Hopefully you had a chance to solve. Let's get right into it. So first things first, let's draw a little picture. We have a projectile is launched. I'm going to assume it's from the ground. I'm going to draw the ground. We're going to draw a little cannon, and the projectile is launched like this. So that is the motion roughly that it goes in. we know that the angle theta is 30 degrees, and we know that the initial velocity is 20 meters per second. All right, so now that we have a visualization of what we are solving for, we're going to go into our first general step, which is split velocity into components. So what we're going to do, what that's going to look like is we are going to have Vx is equal to V naught cosine theta, which is just 20 cosine of 30, which is equal to about 17.32. And then similarly, let's solve for the y. We have V naught sine theta. So this will be 20 sine 30. And this is equal to 10. All right, so what this means is if I take this, I'm just going to draw this like this. If I redraw this component, so this is my V naught, I'm going to draw in blue. My Vx is going to be slightly like this. This is my Vx, and this is my Vy at initial. So I'm going to put a little sub-zero like that, because, and the reason I put the 0 there is because as this projectile moves along this path, the y component and x component change. Right, as it reaches the max height, Vy becomes 0, and so on. So, but my Vx and my Vy, this is what they mean right now. So let's go into the next step. We're going to solve for, I'm going to solve for time, just because when I looked at my formula sheet, I found this formula V is equal to V naught minus GT. And we want to know the time in the air and the max height. So we know that at the top, at the peak, our vertical velocity is 0. So I'm at max height, Vy is 0, right? So at this point, we only have horizontal acceleration. It is not accelerating up or downwards anymore at that point. As soon as I cross that part, we now have velocity in the y direction going down, but right at that height point, at that peak, velocity in the y direction is 0. So that allows me to use this formula right here. So I'm going to say Vy, because we have negative g, and this in the formula sheet is usually given by a, but as we know, a in vertical is g. So to continue this, we know that Vy at peak is 0. We know V initial is in the y direction is 10. So I'm going to say this is at peak, and this is y, minus 9.8 times t. Now we just solve for t. So t, the time it takes to get to the peak, is 1.02 seconds. So this is t peak, right? However, that is not what the problem asks. The problem asks, what is the time in the air? but we only solve for the time peak, the time it takes to get to the max height. However, the one beautiful thing of projectile motion is always a parabola. So the time it takes to get to the top is just 1/2 of the whole time. So time total is equal to 2 times time peak. So our total time is equal to roughly 2.04 seconds. So there you go. That is the time it takes in the air. If you have any questions, please write in the comments and I can explain further, but hopefully that kind of cleared things up about how to split this up into components. Again, that scavenger hunt of I don't know how to get the full time, but I know how to get half of the time, the peak time, and just multiply it by 2. Now let's go into max height. So I'm gonna write it up here just so we can still see the visual. So for max height now, we're gonna use the maximum time that it takes to get to the max height. And with that in mind, I have a formula from the sheet that looks something like y is equal to v naught, I'm going to say in the y direction, times t minus 1/2 gt squared. Y in this case is our max height, so this is what we are searching for. V naught 0 we found was 10, so this is equal to 10. Our t is the time at max, at peak, right? Because that is where we are. So time at peak is 1.02. And then we have minus 1/2 9.8 for gravity. And then t is also 1.02. 1.02 squared. And if you plug that into your calculator, you get that your max height is equal to roughly 5.1 meters. And that is the answer. So that is a typical projectile motion problem where there's a lot of different steps. Each step is part of that scavenger hunt that I was mentioning earlier. But to summarize this up, break it into your x and y components, break your velocity up, make it easier. Kind of look at what you want to get to and what you have, and see what formulas get you there. And whenever you find a formula or a step that connects the dots, figure out, am I solving for vertical or am I solving for horizontal? If it's horizontal, your acceleration is 0. If it's vertical, it's negative g. And then continue solving through the formulas. But there you go. Though that is how you solve that problem. So again, summary, split into your components. If you're ever stuck, ask, am I solving for my y or my x? And remember, physics is just a scavenger hunt. If you're ever stuck, don't worry. Just, breathe and see what you got. And yeah, so hopefully that helps. I will do a few more videos on projectile motion, mostly just practice problems. But again, if you have any questions, please leave a comment. I'll try to respond as soon as I can. If this is still complicated, check out my previous videos on understanding acceleration, velocity, and position. And I'll see you next time.